am Missy Ysahvel Pakingan from 11th STEM, and this is my performance task in basic calculus. Now, the lesson that I am going to discuss is about optimization problem, higher order derivatives, and the chain rule. Optimization problem. In solving optimization problems, the first thing to do is to determine what is to be optimized or maximized, then determine the constraint. A constraint is the quantity that is true regardless of the solution. It can be viewed as a condition that the problem must satisfy. In every problem, there is a fixed value which is a part of a constraint. Carefully analyze the constraint equation. Solve for its variables, and the value of its variable can be used to replace the same variable appearing in the optimization equation. Simplify the optimization equation and find the first derivative. Next, find the critical values by setting the first derivative to 0. Test the critical values either by using the first derivative test or the second derivative test. Example: the sum of two positive is 12. What are these numbers if their product is maximum? Let x one of two positive numbers, y the other positive number. X plus y equals 12 is the constraint. P is equals to xy is the optimization equation. Solve for one of the variables in the constraint. Then substitute the value of this variable in the optimization equation. So let's say x plus y is equals to 12. Y is equals to 12 minus x subs to the optimization equation. P is equals to xy, so what we're going to do is multiply the x to 12 minus x, so it will be 12x minus x squared. So our first derivative is 12 minus 2x. So now let's proceed to set the first derivative to 0. 12 minus 2x is equals to 0. So it will be negative 2x equals negative 12. So the x will be 6. Solve for y. Y is equals to 12 minus x equals 12 minus 6 is equals to 6. Hence, the two number is 6 and 6. Now, let's proceed to the higher order derivatives. Higher order derivatives are derivatives higher than the first derivative. The derivative of a given differentiable function is called first derivative. The first derivative of the given function is also a function, and the derivative of this is called the second derivative. The derivative of the second is the third derivative, and so on. Now I am going to show you the notations for higher derivative. Here you can see the second derivative, third derivative, fourth derivative, and fifth derivative notations. Here are some examples. F of x is equals to 3x fourth power minus 5x cubed plus 4x squared minus x plus 8. To get the first derivative, you're going to multiply the 3x to its fourth power and 5x to cube, 4 to squared, then x is equals to 1, and you are not going to put down the 8. So the first derivative is equals to 12x cubed minus 15x squared plus 8x minus 1. The second derivative is 36 squared minus 30x plus 8. To get the second derivative, you're just going to do the same procedure. Just multiply the 12 to its cube, multiply 15 to squared, and put down the 8 without copying the x. To get the third derivative, just multiply 36 to 2 and put down the 30. So the third derivative will be 72x minus 30. And now the fourth derivative, you're just going to put down the 72 without copying the x. Here's another example, and I'll explain it clearly. To get the first derivative, you're going to put down the fourth power multiplied by x and raised to 4 minus 1. Next, put down the squared and copy the 5. And the last, just copy the 12 without copying the x. So the first derivative will be f of x is equals to fx cubed minus 10x plus 12. To get the second derivative, you're just going to put down the cube, copy the 4x, and raise to 3 minus 1, then copy the 10 without x. So it will be f of x is equals to 12x squared minus 10. And for the third derivative, you're just going to do the same procedure. Just copy the squared and copy the 12x, so it will be 24x. And for the fourth derivative, you're just going to copy the 24 without copying the x. Let's proceed to the chain rule. If u is equals to g of x and y is equals to f of g multiplied by x, then dy is all over to dx equals dy all over to du multiplied by du is all over to dx. Example, differentiate y is equals to 4x plus 3 squared. Using the chain rule, to differentiate y is equals to 4x plus 3 squared, you're just going to put down the squared, copy the 4x plus 3, raised to 2 minus 1, and put the chain rule d is all over to dx and copy the 4x plus 3. Next, just copy the 2 multiplied by 4x plus 3 raised to 1 times 4. To get the final answer, just multiply the 2 to 4, so it will be 8. Then multiply 8 to 4, so it will be 32x, then 8 to 3, so it will be 24. So the final answer is 32x plus 24. Here's another example. F of x is equals to 2x squared plus 8 squared. What you're going to do is just put down the squared, copy the 2x squared plus 8, then raise to 2 minus 1. Put the d is all over to dx, then copy the 2x squared plus 8 squared. Next, copy the 2x squared plus 8 squared, then 4x squared. So it will be 8x multiplied by 2x squared plus 8 squared. To get the final answer, just multiply the 8x to 2x squared plus 8 squared. So it will be 16x cubed plus 64x. That's all. Thanks for watching.